in the free body diagram, next to that, we have to just consider how to keep the body in equilibrium conditions. I am going to just give an example to consider as a string. A string, it just considers the number of wires, two wires connected, where you have two weights two wires are connected like this, one and two weights are there. Okay, I'll consider this point A, this point B, this point C and this point D. The point B, it is weight due to W, weight at point B. Some weight is fixed and this is weight C. Both weights are equal, some kgs considered to be equal. Okay. Now for this setup of a wire which has say two strings or wires, whatever it is, this point B, C, we will have to draw the free body diagram, right, by considering all the forces which is directly applied to these bodies. How do we go about it? Basically, starting, we have to consider, since there are 2 points B and C where the weight is been fixed, I will just write first for FBD, free body diagram, body diagram at point B. Okay, FBD at point B. How will you draw? I will draw a separate sketch, or I will just consider the forces applied at this weight. First thing I will write is weight due to the body, it is WB. Is it correct? The next one, there is one string joined in an inclined position which keeps the body holding. From the point B, there is one more string which is in the horizontal direction which is connected to point C. So this is a force which I can indicate in this inclined fashion, and this is an horizontal line from the point B to C. So this becomes your point B. Now I have to decide that how does I should indicate the arrow mark. This arrow mark I have drawn it down because the self weight of this body will always pull down. No, it will be pulling down. So I am just indicating weight as and downward force. Okay. Now to keep the body in equilibrium condition means stable. It should not become imbalanced, or it should not oscillate. So point B here, I will just consider a force which is in the opposite direction, because if this string is holding a body, it is pulling towards point A only, this wire will be stable. Is that right? It will be just pulling this to outward from this direction. Say this is the body weight B. From this the string is attached and the body has to pull it. If it is in the pulling action only, the body will be stable. Suppose it is pushing, it will be imbalanced, because this condition will not be there, it will just oscillate. Or that force is about inclined one. From this point A, this string has been pulling the point B. Right. Now I will write here, you see it's your tension at point from B to A. Right? It is tension from point B to point A. It is pulling towards it. It is holding it. And what about this one? If this is also pulling, which is pulling towards point C only, the body will be stable. See, one force is like this. This is the weight. If this is pulling towards this side, this body also should keep it in equal. Maybe these both are equal. The force is same. It should keep in balance. If this is pushing, it will come this side, because this is already pulling action. If this is in the opposite direction also, it may go in the other direction. But this body, two weights should be in stable condition like this. So suppose this is body B and this body A, and the string is like this, right? So it should either pull, and this is also should give an pulling action so that body is stable. If this pushes in the opposite side, it will go like this. or if this inclined force is also pushing in the opposite in this direction, it will may oscillate. So this we have to keep it in equilibrium condition, which is not moving either to the left or to the right hand side. Okay. Now in that consideration, I'll just write this is again a tension from B to C. It is tension from point B towards C. This is tension from point B towards point A. It's TBA, it's TBC, and point the consideration what we are considering the point is B, and the weight self weight of the body is WB. Is it okay? So you have to understand why we are writing this arrow mark in this fashion. You should ask me a question, sir, why not we should not draw this arrow mark opposite side? Because if this body is being pulled by this, and there should be an opposite force also to keep the particular string in stable equilibrium. If you keep on this pulling it, what will happen? It will just come out. There should be a pushing force from this point 1, or I can say this point B due to the weight has to pull the string, which means it applies tension to this string downwards towards it. That's also there. So I should have a tension from point T of A to B also, right? As well as opposite side for this C is applicable. Now I am just talking about the free body diagram at point B only. That's why I didn't write the other forces which is not required here, because I am talking about only the free body diagram point. This first. Now I will be drawing about free body diagram at point C, it's D, C. This is the weight attached, point C. How to draw this now? Very simple. First thing, you will have to always draw the weight. Vertical, it's C. Weight at point C. Then, first the one, at inclined direction we have tension from the point C which is pulling towards point D. I will just indicate in this are marked tension from point C to point D. From C to D, the first letter indicates from where it been pulled off, C to D. Then again an horizontal line which indicates again from C to B. It's tension from point to tension point B. So this becomes, I hope you can understand, this we are indicating the forces at particular, first diagram shows that forces at point B, free body diagram, and this at point C. Is it okay? Now when you club together, I need to write a final diagram to show that the body is in stable equilibrium. That is, there is no imbalance, there is no vibration, it will be stable equilibrium. How will I write it? Shall I use this sketch alone, or I will go for other final sketch so that you better understand? The same body, I will just like this. Is it okay? I will indicate say point B and point C. And okay. And this. Is clear? I am just writing all these sketches as it is. Just clubbing together. You see, I will be writing this point A, this is D, point B and point C. This is my weight at point B and this is my weight at point C. Right? Now, this is what the arrow mark shows. This one first. Tension from point B to point A. TBA. Next one, TBC. Tension from point B to BC. B to C. Again, when you come to body number point C, tension from point C to D. See, I am just clubbing together the two sketches. I am not doing any new thing. It is just clubbing the two sketches to show the final sketch so that the body is kept in stable equilibrium. Is T to CD, TCD, this one, and TCB is again here at this stage, TCB. Is that right? But from the point D there should be a pulling force towards D should pull C up so that it is again balanced. Because C is pulling down, it is pushing here opposite. Again the same thing at point A also. I'll write here tension from point D to point C. T from D to C. Again from A to B. It's again tension here. Tension from point A to B. TAB. So this is the final sketch which indicates clubbing two sketches, and this is the actual diagram. This becomes your complete free body diagram. Complete FBD to keep the body in equilibrium. Body in equilibrium. Equilibrium condition. Now this can be solved to find out the forces applied just by using any the laws what we have studied as Lamy's theorem and some other principles. See, by nature, if one body is pulling towards other side, to keep the body balanced, another body has to again pull it towards opposite side. Is it not? I'm just holding this in this direction. If this is more weight, it will go down. That means I'm just pushing it down. If this one is giving more pull, this whole weight will come towards this direction, which means there should be a force which should equally balanced to keep the body in stable equilibrium. It should not move to the left or to the right or to the inclined position or to the down. So I can say this inclined value of TAB should be equal to TBA in this direction. I'll say like this: tension from A to B should be equal to tension from B to A. I'll write TAB is equal to TBA. Right? Hope you can understand, because if this condition is satisfied only, this weight will be balanced. Right? Again the same direction here. Tension from TD to C, from point D to C should be equal to tension from C to D. This condition is to see that two forces are balanced so that the weight are kept in equilibrium condition. Okay? And when there are two forces which are in the opposite direction and the nature is same, okay, that is simply nothing but called as two force principle. For any point you consider, when there are two forces in opposite nature, acting opposite nature, it's called two force principle. This is used to solve, just to find out TB or TCD. Okay, like that everywhere. This TBC, again here from B to C there should be a force TBC, and this is TCD. This should be in a value so that it keeps the body in equilibrium. So the purpose of this diagram is to see that the weight at point B and weight at point C are kept in normal balanced condition like this. Suppose consider this is one weight and the other weight. It has to either, it should not move towards the inclined direction or to the left or right to the down. So this becomes the total free body diagram here. After this you consider one point, either it is point C or point D. We can, what is this actually number of forces applied here? 3 forces at point C. Okay, you can ask me question, sir, there is TBA only, but opposite there is TAB, which will be balanced. If TBA is 5 Newton, it has to be TAB should be also in 5 Newton. So I can take one force so that it makes at point B the number of forces applied is 1, 2 and 3. We can solve it by Lamy's theorem. Lamy's theorem. What is that? We will again draw a diagram. You will have 3 forces going in from the point, it is going away. You will have alpha, say beta and gamma, which is already I have explained. The force whichever you wanted, suppose this is force A and this is force B and force C. Okay, so you can kind of take out the sign of the angle between the other two forces. If I want force A, I'll add it here. If I want force A, it is FA by sine of A is here, B is here, C is here. Okay. So sine of the angle between B and C is, say, alpha beta, is gamma. Sine gamma is equal to, and FB of sine alpha and FC of sine beta. This is again Lamè's theorem, which says the angle between other two forces they are considering, sine of the angle between other forces. Okay. So if there is three force, we can go for Lamè's theorem, or you can go for equilibrium of solutions. It's finding out sigma A and sigma H and sigma V, horizontal forces, vertical forces. Then go for result, right? Then we'll see a few sketches where an actual free body diagrams are shown, so that further problems can be solved easily. Now, I've just drawn two sketches. Just an example to show that a body is in equilibrium condition, and how do we draw a free body diagram? Okay, and then I'll go for a problem to solve. So before going to the problem to solve, get the answers, we just see an example sketch. There are a number of sketches given in the textbook or reference book. We'll have to first go through these sketches and try to write the exact free body diagram, so that you will understand the different types of forces applied and how do we indicate in terms of free body diagram. And for this body, suppose example, this is a ball, okay, at point B, the center of the ball, there is a string connected, and this is considered to be a vertical wall, and this ball is leaning towards this wall, and the point where it exactly touches the wall is point C. Okay, now B and C is 2 points, and this point I will take it as point A, where it is the string is fixed. Just it's in a wire or a string consideration. Now how do we write that free body diagram for this? First is self weight of the body, weight of the body, and this is a straight line, vertical, and next is a force which is in inclined direction. It is tension from body B to A. It is holding. I write like this: tension from B to A. Clear? And this is a reaction because it is touching. So reaction from this point. Either you can write towards that side or towards this side. I will show, since it is going towards right hand side, I will show from here. It is a reaction at point C. RC you can write. Clear? So these three becomes the free body diagram for this point. Now using Lamè's theorem or equilibrium of solution, whatever it is, we can use it to find out the solutions. Right? When there are normally three forces, it is easy to solve with Lamè's theorem, which is a simple. We will get easily the answer, right, within very minimum time. And for this sketch, the same sketch, it is shown in an inclined direction. Just see, it is a vertical wall. It has been tilted to an angle. Now, the same sketch, I can write first the vertical weight W at again point B. Okay, and what about this string? Is again inclined. I can say to direction, this tension point B to A. This is point B. This is point B. And what about this? Is again a reaction, but it is in the inclined fashion. This was in exactly in horizontal direction, the inclined fashion. I can show it up like this. Either like this or opposite direction. I can write it. This is B and this. This is what? Reaction at point C. Now to find it, if you know one value, other values can be found out. So this is the, like this you have some 11 or 12 sketches in the reference books, which will make you to clearly view a picture and immediately write a free body diagram. With this we can go for solutions. Now there is an example here I have given, an electric light fixture. Okay, I was talking about your connecting from the main switch of a room. Suppose you consider a bedroom. Near the cot, you will have to connect a normal, take a wire and fix it to just make a fix a bed switch for your convenience. Like that, there is one fixture. There is a horizontal, it's a ceiling or a wall, and then to the vertical wall. In that area, it is connected with two wires, two strings. An electric light fixture. Fixture is the area where you have some connections. Weighing, which is have a weight of 150 Newton. This is 150 Newton. Okay. Hangs from a point C. Where is point C? At point C. By two strings. It is hanging at point C, which is connected by two strings, AC and BC. Where point is A, this is point is C, and point is B and C. So these 2 points, your A and B are fixed points, or it is a point where the strings have been fixed, and the point C is the where your weight is fixed. It will be hanging down. AC and BC as shown in figure. Determine the forces in this string, AC and BC. What are the forces which is kept so that the body is kept in equilibrium condition? That is the question. Now what to do? Only one angle of 45 degrees has been given. The remaining we have to find out the solution. How do you find out? First step. Step 1, to draw FDP, FBD, free body diagram. How do you draw? For this point C, we are concerned about point C only. We are bothered about point C. At point C, what are all the forces incurred? For that you find out an answer, you get the forces in string AC and BC. Now, I will take this point as C, your point C. First is the self weight acting downwards. It is given as 150 Newton. Okay. And there is an inclined force to some direction. Basically we write tension from point C to B. It is TCB. Is it okay? It is pulling. It has to pull so that to keep the body in equilibrium condition. Then tension from C to A. I'll write C here. It is in this direction. It is TCA. Is it clear? It's pulling it. And this is given as an angle of 45 degrees. This is the setup of a free body because we are bothered about the point C only. The weight is attached to point C. To keep this weight in balanced condition, what are all the forces of this TCB and TCA? That we have to find out. Is it clear? Weight is known. Unknown is a force which is at this string B to C and string A to C. This is what wanted, right? Now, I'll just erase this part because it's again for your understanding. Hope you can do it better because the number of sketches, if you go through the book and you understand, this problem solving will be very easier. Okay. Now, this is step 1. You find out the free body diagram.